So screen visible na?
Yes, sir.
Yes, sir. Screen is visible.
So this is about only the ideal gas equation. So now we will come along like mm, work done. So some assumption we will take here. Let's suppose this is our system. So work done on the system, what we will take?
Negative.
Positive.
Negative, sir.
So and the work done by the system will be equal
Positive.
to positive, and work done on the system will be negative.
Negative.
So similar for heat we will take some assumption. Okay. This is the system. Heat given to the system, what we will take?
Positive.
Positive.
And heat rejected by the system, we will take negative. Can anyone try to iterate the first law of thermodynamics?
Energy neither can be created nor to be destroyed.
Okay. In some quantitative way, this is just a theoretical meaning, like neither created nor destroyed. We
So
will
total the universe is conserved.
so
For a
Net
cyclic
heat
process,
network.
work done is changing
Net
heat.
heat transfer is equal to network transfer.
एक second, your voice is not coming properly. You can say again. Hello. Uh, okay, first tell like
For a cyclic process, change in work done is change in heat.
which process?
Cyclic process.
Okay, for a here you told like for a cyclic process. And so main if in another words we will say like first whenever some people will ask you what is the first law of thermodynamics, then five terms you have to remember actually. Like it
Q
is
is
valid.
equal to U plus W.
Okay, it is valid for closed system first. Okay. For a closed system, network here someone is saying like work interaction should be equal to the heat interaction. Work interaction might be from two ways. Okay, here like it, let's suppose this is ts, here q input and here q output, here work output and here work input. Okay, so here what we have to take, net interaction we have to take. Okay, like what amount of heat you have given and what amount of heat has been rejected. So q in minus q out, so net heat interaction we have to take, net energy interaction. So for a closed system undergoing a cyclic process, net heat interaction would be equal to the net work interaction, and both unit should be same. Like it should not be like heat you are expressing in calorie and work you are expressing in the joule. So units would be same. So five things you have to remember. Like so for a cyclic process, what would be the del Q is equal to del W. Hmm? Is it fine?
Yes, sir.
So can anyone let me know what is the limitation of this?
Cannot path define नहीं कर सकता. Cannot define path where heat is going or rejecting.
Apply to only control
Other
mass system, not
not
only
applied.
What?
apply to only control mass system.
Valid
Here
only
we
for
cannot
cyclic process.
here we cannot say about the direction of the process, whether it is possible or not.
This is the limitation of first law only. Complete first law limitation is this. So direction we will define by second law. So here a problem with this equation is like that this is valid for only cyclic process. Okay. Only valid for only cyclic process. We cannot use this for a single process. Like some processes like this PV. So we cannot use this del Q is equal to del W for this, right or not? So I will not go in deep detail how it came. Like so, when you might have studied in your del q is equal to del q is equal to du plus del w. Hmm? Work. Actually, it is not dE. So it is most general thing, I think. So can anyone tell me know what is under dE? dE is the internal energy. Okay. So total energy, it is total energy. It is comprising of two things: microscopic energy and microscopic energy. Microscopic energy, internal energy. Internal energy. Actually, a lot of assumptions are there. So many times when question come out of these assumptions, then we will start making mistakes. If on the track question will come, then we will not make mistakes. So what will come inside the energy? Like two things. One is the kinetic
Kinetic energy, potential energy, vibrational energy.
all the energies that will come inside. So this will be the comprised with the macroscopic, like a complete system we will take. So macroscopic part it is the microscopic. And this work done will be comprising of the frictional work and all type of work interactions we will take, like chemical energy and whatever changes are there. Friction, PdV work, and we will take like one example chemical energy. So now we will take some assumptions. Like here we are taking for the energy, we are neglecting kinetic energy plus potential energy part. Assumption for this is that like the system is our system is in the rest and that we will the on the earth level. Potential reference we will take that one. So these we will consider as 0. So dE will convert it to du.
Yes, sir.
Hello, hello.
Yes, sir.
So del q
Sir,
will
yes.
become du plus and here all irreversible these like friction is the irreversible process because we are losing some work here and the chemical energy all we are neglecting, so only PdV work we are considering. Okay. PdV work is a reversible process. Can anyone know?
Yes, sir. It is internally reversed.
So only here what assumption we have taken, like we have neglected all microscopic part and all irreversible things we have neglected. So this equation is valid for the reversible process. Reversible process and now single path means individual processes we can use this equation. Okay. So this equation we will use. So two types of systems we have studied. Systems two types. Now I will ask you formulas. Someone knows, then let me know. Otherwise, I will write. Okay. So I will not deriving all the formula. I will directly write the formula and try some questions on that. That would be more better. So first we will write the work done for the closed system. I think along in one table we will write for open system. So this formula try to, if someone remembers then it's good, if not then keep on writing. Okay. So first process we will take volume is equal to constant. So can anyone know what is the formula for closed work done?
Zero.
Del U is equal to NCV
1 minute. First I will tell like for the closed system work done will be the integration of PdV. Okay. And work done for the open system is open closed system, that is confirmed to you all.
Minus VDP.
minus VDP. Okay. So if it is in the like PV curve, so like and this is the process. Let's say. So for the closed system, we will take the area under the PV curve on the along the that y-axis. We will. This is for the closed system. Closed system, and for the open, same thing would happen in the on the this y-axis, pressure axis, because here variable is dp. Okay, so this is the difference in the open and closed open system. So can someone let me know, like in steady flow energy equation, anyone knows?
Yes, sir.
Hmm? Okay, so I will write and you let me know if you know.
The potential energy plus kinetic energy plus work done is equals to heat plus
Okay, let's suppose for turbine we will take. Turbine potential, kinetic, everything we neglect. Na? So here what is like animal speak. So here what is like
Difference in enthalpy will give us turbine work.
let's suppose H1 is the incoming enthalpy, and Q is the heat going out, and H2 is going enthalpy, and we will get the W1. Okay, like that we will get. So incoming energy is H1 plus Q. So outgoing would be H2 plus W. Now let's suppose it is insulated. So Q would be 0, right? Actually, I am going to ask one question here. So keep on understanding question what I am going to. So here open work done, what I have did minus VDP. And here if we have insulated that our open system, so work done would be H1 minus H2. Understood or not?
Yes, sir.
So this is also for open system, right? And this work done is also for open system. So what is the difference in both?
sir what?
This one formula for open system is this. Okay, minus VD.
Sir, the first one is H1 minus H2 is about the difference between the enthalpy, and the second one is about the volume.
No, nothing like that. It is written only. This is I said this is the difference of enthalpy. What is the difference between heat?
Sir, the enthalpy difference is taking place at a constant pressure.
No, no, no.
So in enthalpy difference, are we taking care about the flow work?
So work this open system, all whatever open system is there, na main work in compressor we are giving work. The flow devices are there open system. So
Sir, maybe here pressure change is considering. Due to pressure change, work is considering, and here all parameters are considering.
no, it's not like. So pressure
For
change,
open
pressure
system,
in every process pressure will keep on changing. But not
So
for
the
open
above one
system,
is
we are
valid
considering
only
the
for steady
constant
flow.
volume process.
so. My question you understood now what I am saying.
Yes, sir.
Yes, sir.
I will give one hint, and then you will try. After the class we will discuss that. Okay. So H is equal to U plus PV, right? So DH, this is what basically did, if you will write this, dW is equal to DH. Basically this is one. Na? Hello.
Yes, sir.
So we will see here, and after that I will let. So try to differentiate that part and come to this. Okay. This you will you may get the answer. because this is a conceptual part. Okay, because sometimes you will make mistake, like you will because in power plant you will go and do questions like that, and here we will write this. So when sometimes confusion will come, what to use. So you will come to know. Okay, no issue. So now I will write the formula for them. So for the constant volume process closed system, what would be the word? Anyone?
0.
Zero. Right? Understood now how it will become zero? Everyone. Anyone, if you are not taking, if anyone is confused, not sure, then you can easily say like I'm not able to get. I will get. Don't go like someone said I know and I will skip. Not like that. Let me.
Sir, please explain, sir.
So constant value process. If anytime screen would not be, you are not able to see, then let me know. PV curve. How will be the constant value process like that, na? Let's suppose it is happening 1, 2, 1, 2, 2. Okay. Hello.
Yes, sir.
Yes, sir.
So what would be the area of this along the y axis? 0, na? Only straight line. Straight line area is 0.
Only straight line. Yeah.
So this would be 0. So first I will write for the closed system, then open system will be. And this table you learn because most of the question will solve from for work interaction. For constant pressure process, what would be the formula? Because I will just draw one line. P,
Sir, NR delta T.
P delta V.
PV2 minus V1.
So here what if one denotes means a subscript would be 1 and 2 means 2. Okay. And pressure for P1 is equal to P2 here, right? So we will write P1 V2 minus V1. And PV is equal to NRT, PV is equal to MRT we know. So P1 V1 is equal to MRT2 minus T1, like that we will also do. Anywhere if you are not getting, let me know. Huh? And
Okay, sir.
constant temperature process, what would be the word?
So MRT ln V2 by V.
We can write anyways. P1 V1 is equal to P2 V2. That is the equation for the that isothermal process. Okay, I am considering
Sir,
some basic part you knows like that. If you are somewhere you are not, you don't know, let me know. I will try to explain in brief.
sir, how we get this formula, sir? Temperature constant, sir.
Actually, this all comes from this integration of PdV. Okay, so listen. So PV is equal to MRT. Okay. If a temperature is constant, M would be constant for a system, R would be constant. So this whole part will become constant, right?
Yes, sir.
So for isothermal, PV is equal to constant. This would be our equation. So when we will do PdV, so what is the P from here? C by V, right? We will put C by V dV, and from here to here V1 to V2, right?
Yeah.
So when we will
Sir.
solve this, then it will become C ln V2 by V1. So what is the value of C? This is P1 PV, right? So we will PV ln V2 by V1. So for if this is the process 1 to 2, this is 1, this is 2. So equation would be what? P1 V1 is equal to P2 V2 is equal to constant. This would be happen, na?
Yes, sir.
So P1 V1 would be NR, sorry, MRT1, and P1 V1 would be equal to MRT1, and P2 V2 how much? MRT2.
MRT2.
So anyways we are able to write P1 V1 ln V2 by V1, P2 V2 ln V2 by V1, MRT1 or MR2 T2. Understood now what I'm saying?
Yes, yes.
Yes, yes.
And this V2 by V1, either write V2 by V1 or P1 by P2, and this is also correct. So now coming to here, in one all formulas of our table.
सर वर्क डन इन क्लोज सिस्टम एंड ओपन सिस्टम वाला फॉर्मूला कहाँ से आया सर, ये थोड़ा पता लग जाएगा।
कौन सा?
वर्क डन इन ओपन सिस्टम और क्लोज सिस्टम का जो इंटीग्रल पीडीवी और माइनस वीडीपी वाला है, ये थोड़ा समझ नहीं आ पा रहा, मतलब ये आया कैसे। सर मेरे को मतलब वर्क डन का इतना पता है, जो रेजिस्टेंस फोर्स होता है उसके अकॉर्डिंग फाइंड आउट करते हैं, बस ये नहीं पता कैसे आया।
ये क्लास के बाद में तुम पूछना बताते हैं, अभी पहले कर लो।
जी सर, थैंक यू।
Sir, can you kindly tell the difference between that H1 minus H2 and minus integral VDP?
Yeah, that I left to you, and anyone in you try, keep on trying. If anyone's mind comes to answer, then let me know. Otherwise, I will after end the class that will let you know.
Okay, sir.
Because if in those things we keep on indulging, then the rest of things will keep on stand still. So for PV is equal to constant means isothermal. What is the formula? P1 V1 ln V2 by V1 or P2 V2 ln V2 by V1 or MRT1 ln V2 by V1 or MRT2 ln V2 by V1. Anyway, you can write. Okay. So this is for the isothermal. So now coming to the PV to power gamma is equal to constant. Which process is this?
Adiabatic.
So what is the work done for this? Same way, just like last here we have derived. Here we have derived, like here what is the equation? PV is equal to constant. Here we will write PV ki power n is equal to constant, P is equal to C by V ki power n, and keep on deriving. Okay, sorry, gamma here. So same way both will have. So when we solve that, what answer will come? Anyone knows?
MR T2 minus T1 by 1 minus 1.
MR next.
T2 minus T1 divided by 1 minus gamma.
Here adiabatic we are considering. Anyone correction here?
So P1 V1 minus P2 V2 upon gamma minus 1.
Sir, it must be T1 minus T2.
V1 V1 minus.
No, it's correct.
Which one correct?
So you
So
see,
it
he
is
said 1
T1
minus
minus
gamma.
T2. Okay. T1 minus T2. You have to remember like initial minus final over gamma minus 1. Okay. Like that you will remember. So for adiabatic work done is MR T1 minus T2 or gamma minus 1, or if you are knowing the pressure volume, go like that. Okay. Now coming to the next process.
Sir, why not final minus initial, sir?
That directly I cannot tell this here. You when you derive PV ki power, sorry, PV ki power gamma is equal to constant. Here you will put C by V to the power gamma. Now C by V to the power gamma dV. Now you will when what is the this is what V to the power Vi or Vf. Okay. V to the power C into V to the power minus gamma na. Hello.
Yes, sir.
Yes, sir.
So that when you will integrate, what will come?
minus gamma plus 1 upon minus gamma plus
Uh,
1.
when you will upon me, what will come? 1 minus
1
gamma.
minus gamma.
And here will come like Vf minus Vi. Like final minus initial you will write na. I am not doing in comprehensive will, just let you know. And when will minus common from top side and bottom side, then that when initial and gamma minus 1 will come.
Yeah,
Okay.
got it, sir.
So not I'm going in the descriptive. So now coming to the same way we will do P to the power n. Which process is this? Polytropic. Hmm? What is the work done here?
Same, sir.
In
And the
place
gamma
of
replaced
comma,
by
it
n.
will be changed.
Okay. So now only for this is what for closed system. Now coming to the open system.
So
Now
slide back, sir.
when you are done, let me know.
Yes, sir. Done, sir.
For the open system, quickly we will write. V is equal to constant. What would be the work done?
V minus pressure difference.
Here E dV. Let's suppose here 1, here 2. Minus VdP is no?
Yes, sir.
So minus volume is constant. So P2 minus P1. So V P1 and for constant pressure, what will be the work done?
0.
For open system, this is the process. And area when we draw in the y-axis, it will become 0. And now coming to the isothermal. Temperature constant. What is the work done here?
Same as closed system.
Anyone can prove how both work done will be same?
Sir, it is rectangular hyperbola. So the area is same in both.
Question is PdV is equal to constant. This is not the actually proof. So this is just for the layman word, so you can make anyone understand. So if you differentiate both sides, what will come? Differentiation of constant is 0.
PdV plus VdP
PdV
is
plus
equals to 0.
VdP is equal to 0. So from here what will come? PdV is equal to minus VdP. Right?
Equal representation and diversity in AI is super important just because AI
Sir.
is all.
Hello?
Hello, sir.
Uh-huh.
Sir.
Hello?
Sir.
Yes.
Anyone is asking anything?
Sir, is it practically possible? Both words are same. I mean, you have just a Latin word.
Uh-huh.
Means it is true always.
Actually, this is whatever I am writing, it is completely reversible things we are doing. And practically nothing is reversible and like that. So losses are there. So if you are going to do that way, never ideal things are never possible. No? So ideally just we are trying to achieve those things.
Okay, sir. Understood.
So work done would be the same here. So whatever four formulas written last time is valid here. Okay. V1, V1, ln, V2 by V1. So same thing if you anytime you forgot like PV to the power gamma is equal to constant. Like adiabatic is here. And what is the work done? Anyone knows?
Gamma times of work done closed.
Okay. Gamma times of P1 P1 minus P2 V2 over gamma minus 1. If sometime you keep on forgetting, let's suppose. So PV2 same thing you can come to. So when you derive PdV plus gamma times of so same way you can do, but now I am not going there. So PV to the power n is equal to constant. What with the work done here? And times we keep this all those formula in note. Over n minus 1. So these 5 formulas here. Okay. Hello.
Yes, sir.
Yes.
So now coming to the now you can able to find the work done for any now you will able to like find the work done for any process if you know the process name, right? Hello.
Hello, sir.
Yes, sir. Yes.
Now we'll coming to the heat.
Okay.
So for the volume constant volume process. So what you know, like del q is equal to du plus pdv, right? Hello.
Yes, sir.
Yes, sir.
Yes.
Yes.
So for constant volume it would be 0, right?
Yeah.
So heat basically heat is two parts. Okay, one is the sensible heat,
And one is latent heat.
sensible and latent. So what is difference in both?
In sensible heat, there is a change in temperature, but in latent heat, there is a phase change.
Heat associated with the phase change is latent heat. Okay, right? And here temperature keeps on fixed. So and sensible related with that related with the temperature. So can anyone let me know sensible for one is the solid or liquid, right? And one is gas. So for the solid liquid, both it means latent that sensible heat is not dependent on the process, right? And in
Yes,
gases,
sir.
you came to know like Cp, Cv, and like Cpv की power n means here not constant pressure वाले like so why this happens? Anyone answer?
Sir, because change in volume or pressure in solid or liquid is negligible as compared to gas.
Correct answer. But you can also say like in the intermolecular this is related with the intermolecular forces because CPCV.
Due to molecular randomness, like Brownian motion.
That is right. In the solid liquid, intermolecular force is relatively much higher than the gas. So due to that effect, it happens. Right. Then now we'll coming to the here what process we have considered like volume constant volume process. So dq will be m cv delta t, dt we will write. So it will become du. So and also
Sir, how you wrote once explain, sir, that?
huh?
How you wrote that mcv dt equal to du, sir? Explain once, please, sir.
That's why I written. I will explain. So here del Q is equal to mCV dt. That is right. What is CV? Anyone can define?
Specific heat,
What is the
specific
definition?
volume
Specific
per
Definition.
constant
at
value.
constant volume.
No, no, not saying like what is the name for this? What is the meaning for this?
Means volume is not changing and you are giving it.
Heat given to raise the temperature by 1 degree Celsius at constant volume.
For how much material? It will not depend on the amount of material or what.
Sir,
For
1 kg.
Hello,
1 kg.
1 kg. Na? So CV is the amount of heat given to the substance, like for unit mass substance to increase the unit temperature, right? So for the fluids like gases, it depends on the process. So for it is the constant volume process we have assumed initially. So it is for CV, we will multiply mass and temperature difference. It will become the amount of heat required, right?
Excuse me, sir. I have one doubt.
Speak.
Sir, that for the sensible heat you told for solid and liquid, the value doesn't depend on the process, right? So what is that value, sir?
It depends on the material. Just like for the water, it is 4.18 kilojoule per kg Kelvin, kilojoule per kg degree Celsius, and
So the formula of heat remains the same, or just the
for that time it will become mc delta t, not like it will not keep on changing with the this process. Okay, here you will know the value of c and mass, what mass is there and what temperature is increasing or decreasing. So
so
accordingly,
for whatever process it is, for solid and liquid, sensible heat will be mc delta T only.
okay, yeah, if
Okay.
phase change is going on, so m into l we will write along with that. Okay.
Okay.
So it is for the this, and now first when we put the first law of the thermodynamics, del q is equal to du plus p dv. So anyone knows the what is the difference of path function and point function?
Yes, sir, yes.
On the path. Point function depends on final and initial state.
Sir, path function depends on the path from the process stages, and point function depends on the initial final point only.
So delta u is what? Point function is path function.
Point two.
Point function.
It function.
So it is the point function, so it will not depend on the path. Means in another words we will say like point function are those variables which does not depends on the its past history, how it came, like which path it is followed. It only depends on where initially you are, final where you are. Huh? So means it is initial and final, how you came here, whatever path you have followed, no matter. Okay, this value will same. So du is the point function in internal energy, because it depends on, for the ideal gas it is the function of only temperature, right?
Yes, sir.
Yes, sir.
U is function of only temperature. So temperature for any point will not change whatever path you will follow. If you come this point by any route like that. So so value of du from here it will come mcv delta t. So from here what we come to know, like whenever we have to find the value of internal heat, internal energy, sorry, whatever we have to calculate the amount of internal energy, we will use mcv delta t, right?
Yes.
And for the constant volume process, it is same as the amount of heat given to the system, right? So here this happens. So now coming to the constant pressure process, what is the value? And
MCP dt.
so everyone knows like Cp minus Cv is equal to R, right?
Or yeah.
And one more relation, Cp by Cv is equal to gamma.
Gamma.
So many times in the question they will not give you value of Cp and Cv. They will just give you the value of gamma and R, and then you have to calculate Cp Cv, right?
Yes.
So these two formula you also can write. With these two equations you can find out Cp is equal to gamma R over gamma minus 1. Cv is equal to R over gamma minus 1. You can easily derive, okay? No issue using these two equations, right? Hello.
Sir, hello, sir.
Yes,
Sir.
Hello.
Yeah, now what are you saying?
Sir, that QP at constant pressure MCP as well as we write as DH, no, sir. Change in enthalpy.
Yeah, that you can write.
That's all I'm telling.
One by one we will go. Okay. Now Q for the temperature constant. Now we know that del Q is equal to du plus PdV, right? And from the last part we come to know like what is the du? mCv dt, right?
Yes, sir.
So if the temperature is the constant, say then what would be the value? 0.
yes, sir.
So del Q will become PdV, right? Like same as last formula, right? Work PdV is what? Closed work done, na?
Yes, sir.
So PV ln Vf by Vi means for the isothermal process, open closed system or heat interaction formula would be the same for all. Okay, keep in mind this. This will come into the question. Now coming to the PV to the power gamma is equal to constant. What will be the heat interaction? Hmm?
0.
Can
Sir,
anyone
which,
can anyone prove how 0 will come? Means I'm not going to ask you like how you will prove. Just give me a direction. I will.
Sir, we will add up work done and internal energy, and it will come to zero.
Okay. Like first law of thermodynamics, you will write mCv dt, and I'm doing just not doing just give you the way and you do. So work done for this by PV good power gamma. What is the value? Mr T1 minus T2 over gamma minus 1, right?
Yes, sir.
So in the last part, what is the CV?
R by gamma minus 1.
Gamma
R
minus 1.
by gamma minus 1.
And dt is what? T2 minus T1.
T2
You will
minus
see
T.
like what is it? Okay, understood now? T2 minus T1.
Yes, sir.
Mr T1 minus T2 by gamma minus 1. You will see like it will cancel out. So now coming to the last part, PV to the power n is equal to constant. What is the heat interaction? Anyone knows?
Yes, sir.
maybe 0.
What?
P1 V1 minus
1 minute. V1 minus
P2 V2 by N minus 1
this one.
into gamma minus N by N minus 1.
What? Gamma minus a?
Gamma minus N by N minus 1.
Anyone correction? Here also you are saying like
Gamma
n minus 1
minus
both side.
No, sir, gamma minus 1 at
Gamma
below
minus
P1 V1.
1 minute. One by one. Anyone connect?
Sir, below P1 V1 minus P2 V2, there will be gamma minus 1.
Anywhere you can say. Okay, here it would be easier to learn if you put gamma minus 1. Like it is what? This part is nothing but work done for the closed system. So in other words, what we will say, gamma minus n over gamma minus 1 into work done of closed system.
Sir, can you please explain this? PV is equal to C.
Which one?
Last one, sir.
How it will come like that? You are saying?
Yes, sir.
You nothing, just you mcv delta t, you know na?
Yes, sir.
mcv mr t2 minus t1 over gamma minus 1, right? Like that, and because this value will same, and here you for work done you will put mr t1 by t1 minus t2 divided by n minus 1. Okay, just add and this will come. Just simply add you. Here how we will find 0? Same way you will go and simplify, same thing will go, right?
Sir, one doubt.
Uh-huh.
Sir, for latent heat, is there specific formulas for gases? Because all these formulas are for sensible heat only.
Because listen, gases for what? They are already after the gas. What will happen? When you heat, nothing will go. It will always remain as gas. So when you will keep on cooling, then latent heat will come into picture. But we are not going to cool anyway in the physical process. Like when will the gas will become liquid? Like close to minus 170, 180 degrees Celsius temperature. So till that temperature, we are not doing the process. Right? So
Sir,
that's
for
why
work interaction, is there specific formula for solid liquid gas? Is there any specific difference?
Not getting what I'm saying.
Sir, for work interaction, similar to heat interaction, is there any specific formula for solid liquid gas or something, or it is same for all the materials?
There, because if you coming to the solid liquid, then PdV work is not come to picture, because change in the volume is very less with it relative to the pressure, right? Because it become incompressible thing, liquid and solid. So PdV not coming to picture. That will come into the picture only when it is in the gaseous state, right?
Yes, sir, but what about control volume work, sir? DP, change in pressure.
Where you are saying?
No, sir, like for work interaction in open system, we
Open
told that
system
it
you are
is,
telling.
yes, there we have DP, no, sir. If we have appreciable change in the pressure, we can have different formula for solid and liquid, or it is same, sir?
At that time, there for the you are telling about that, there you will know like what is the value of V, then we are going to use in that our means what Rankine cycle, etc. There we keep on using like for the pump work. You have did some question on that or not? There we will use like VDP simply.
Okay, sir.
So we will, when we will do question, there we will use like we are because pump liquid is there, water, saturated water. So saturated water we will pressure, and we will take like a specific volume as 0.001 and into the pressure difference.
In case of liquids, we'll take specific volume as constant into the calculation.
We will simply dP will multiply with the that specific volume of that.
We will assume that it is isochoric process.
It is isochoric because volume is not going to change with the pressure at all.
Okay, but similar formula only.
Formula would be the same.
Okay.
So heat is done. Okay. So now coming to the one more thing, like we know CV, CP, sorry, not equal, CV, CP, and for the solid liquid C, right? So for the PV to the power n, like CV is a sensible heat, for the constant volume process, specific heat, sorry, and Cp is the specific heat at constant pressure. So what will be the specific heat at the polytropic process? Okay, got what I'm telling?
Sir, please repeat.
What would be the specific heat for the polytropic process, right? Anyone?
Sir, 1 by plus 1 plus
Again, what was it?
Sir, 1 by gamma minus 1 plus 1 by n minus 1.
What is this? Okay, I will let you know you one trick. Here, what is this? Gamma minus 1 over gamma minus 1, right? Just flip this, not a trick, but you may understand later. N minus gamma over n minus 1 will be. And here into the CV. Because you are saying like how dimension will match. So CV for that case we are knowing, and polytropic index n we are knowing, and gamma would be here. So now I will give one question here. For gamma 0 to 0 to n gamma, right? So this is the our one polytropic process. I am not will give the answer for this now. I will ask later. Polytropic process. So uh, generally what we think like it is the system when we will give the heat, then it will do the work, right? Hello.
Yes, sir.
So in the polytropic polytropic process, and our one intuition is like that when we will give heat, then the temperature of the system will also rise, right? Temperature will increase, right?
Yes, sir. Yeah. Yeah. Yes.
So for the polytropic process, we have given heat, but temperature will increase or decrease.
It will decrease.
Okay. So why?
Sir, because the magnitude of work done is more than the heat, so net heat interaction will be, so the total internal energy will decrease.
So with this also you can see, but that's why I just after that some significance of this also you come to know. That's why I put here. This is the what is this? Specific heat, right?
Yes, sir.
So whenever we put the value of n less than gamma, what would be the value of this? Cp with power n, specific heat at the constant at for polytropic. More than 0 or less than 0?
Less than 0.
Less than 0.
It will become negative, right?
Yes, sir.
So specific heat negative means what? Whenever we will add heat, it will temperature will keep on decreasing, right?
Yes, yes, sir.
So this also that's, and that also correct because
Sir, one question, sir. As you're telling that when we are adding heat, then the temperature will decrease. Sir, then if, for instance, if we add heat on the ice, is that the same thing like that?
here specific heat is not negative, na?
Yeah. Yes, sir.
So one person have asked like here work done is more because del Q is equal to KV plus dW. So this is the formula for heat, right? So here anything you can write a value of n, you will come to know that, right? You do and come to know. Put anything. Let's suppose gamma 1.4 and n 1.2. So work of close. So what will be this? Work of close by 2. Getting or not what I'm doing?
I mean, I not understand why this happened.
Just these value I have taken assumed. Gamma is 1.4 and n is 1.2. Following this na, this one.
Yes, this is true. I
And
mean,
this del q came to work done of close by 2. So what is here? Like net heat interaction is the half of the work done. Okay. So del q is del u plus 2 times of del q, right? Del w here. From here we will take. Hello.
yeah, yes, sir. And
Yes, sir.
So what will be the du? Minus of del w, right? Sorry, del q.
Yes, sir. Yes, sir.
Here
Yes, sir.
like specific heat. Sorry, this internal energy keep on decreasing. Means negative, right?
Yeah.
Okay. Now coming to the some mostly entropy question you will from the get you will solve from these three formula. Okay. Write these three formula and then we will solve the question.
Sir, please back the slide, sir. Done, sir.
So del S is equal. Here we will write one entropy formula as the function of the temperature and volume. Entropy formula is the function of temperature and pressure and function of pressure and volume. Anyone knows all three formula?
Yes, sir.
Okay, then start from the temperature and volume.
MCLN T2 upon T1.
Tell about the for the unit mass. Okay, remove one.
Okay, sir. CVLN T2 upon T1
Next.
plus CP upon
No,
CPLN P2 upon P1.
not C. Okay, you coming to pressure. I told about the volume.
Oh, sorry, sir. RLN B2 upon B1.
Okay, and delta S is equal to CP ln
CPLN
T2 by T1 minus R.
minus of RLN.
If anywhere mistake, let me know. Okay, don't. So here
CPLN B2 upon V1 plus CVLN P2 upon P1.
okay, write these three formula first. As you finish, let me know.
Sir, after end of the class, will you get the whole PPT from you? Like as such from.
That I will upload because actually now these things I have discussed with the professor. So he's saying
Yeah.
they will make some one portal from the NPTEL and that portal will be shared. That only that get portal. So individually we are not advised to share.
Sir, may I kindly know when did these classes starts?
Only last week it has been started. But, this is the second class.
Yes, sir.
Okay,
Sir,
next.
one thing.
Sir,
Sir,
in
one
the
thing.
Hello. Tell.
Sir, could you please record the lecture for us because sometimes
That's why
when.
initially you people also let me know about the recording. Just I forgot today. After half an hour I came to like time to record.
Yes, sir. Because sometimes what happened
That's
that
why
when
it has been asked to us to record also. But
yes, sir, yes, sir.
after half hour I started.
Sir, last week's class recording, sir.
Actually, I asked the professor, so he's saying like they will make some arrangement for that and let you know.
Okay. Do you have any Google Drive or as such that we could access that?
Okay. That we will do, but first we finish these things.
Okay, okay, definitely, sir. Thank you, sir. Thank you.
So all formula you put, I think I have given you all formulas. So I would say anyhow we are.
Sir, what is the entropy change for solids?
Huh?
Entropy change for solids. These are for gas, right?
This is the means process dependent. Process dependent. So for
Yeah,
the
but
solid,
these are
okay, let me this
these
is
are
the
for
solid.
gas, right?
This is solid. So here two things may happen. Like you consider liquid, right? Water. You consider water. Sorry, consider ice as 10 minus 10 degrees Celsius, right?
Yeah.
And keep on heating till 25 degrees Celsius. Actually, next class I am taking this question. What you asked now.
Sir, I want to ask that how a path dependent variable is changed to a point function type, like delta q to TDS.
Means how delta Q become TDS? You are saying like that.
Yes, as delta q is a path dependent function.
No, no. Delta Q is part dependent. That you one by one I will tell. Okay. So first minus 10 degrees Celsius. You this is the what minus 10 to 0 degrees Celsius. This will become sensible heating first, right?
Yes, sir.
So here, but volume will not change. You know. Hello.
Yes, sir. Yes, sir.
Yes, sir.
So we will use the same formula, but apart from this CV, this C will become of the for solid ice means C of ice. C of ice is different from the C of liquid, right? Specific heat of the ice.
Yeah. Yeah.
So we will use the specific heat of ice here, and temperature we know. Like we will put temperature in kelvins here, right? Don't put in the degree Celsius, otherwise question will be wrong.
Yeah.
So here 273 and here 263. Okay. And this V2 V1 will be same. So ln1 becomes 0. This part will be discarded. Okay. And then we will give the latent heat. Latent heat is the constant, does not depend on the this temperature of this. So what is the temperature? ml by that constant temperature, right? These things you may not appreciate because entropy is dq by t. That's why I am not telling you. So latent heat we will give here, and again sensible heating will start. So here same formula will use because this formula with this question we will break in three parts. Okay.
Okay.
Now I supposed to do these for five questions, but okay then.
Sir,
I would say like
sir,
you take the screenshot of these questions, and next class we will do.
Yes, sir. Have taken already.
Okay. One question is this taken. Now come to this question take.
Yeah, done, sir.
This.
Done, sir.
Actually, whatever I have told in the class today, everything is from there. Right? So you can do. You can at least try, and if any doubt, then you can ask me. Huh?
Okay, sir.
My mail ID I will go here.
Okay, okay. Okay, sir. So
Sir,
done.
can
Have
you
taken.
show the first question?
1 minute, I will go again. Take care.
Sir, one thing, and if even if we face as such lacking the concept, then could we let you know over your mail ID?
Yeah, let me know, and if I am not able to explain, means not time accordingly, then I will suggest you something from there you can easily get. So don't
Okay,
worry.
sir.
You can ask me.
Sir, in the very starting of this class, you are talking about some app.
That you might have gone like in Play Store. You will because there I will show you in a minute. So just to take the screenshot because most of the for the
Have
gate
taken, sir.
all study material and if something you are this question we have already done. So 6 question would be
Sir,
there.
Sir, kindly come from the first, sir. I missed
Yeah,
certain
again.
questions.
Question. Done.
Yes, sir. Yes.
Done.
Yes, sir.
Sir, please wait, sir. Can you go to the first questions? 1 minute.
Actually, someone is saying 1 minute. I will take the questions for you. Srikant Amgot, who?
Sir, please show second question. Second question.
Okay, entropy part we will theory part and whatever is there I will take in next class and question will give you the questions. Actually, these are the conventional question. Okay, so if you are able to solve these questions in the gate in these questions in one question, two, three questions would be there. Okay, so if you are comfortable in all these questions, would be good. You when you will solve completely, then you will come like what is the issue there. I am not able to do today.
And sir, on today's class, I have some misconception about the reversible process. What you told during that time, I faced bit glitch on my network. Therefore, I didn't listen you properly. So I will ask you on the next class.
Yeah, yeah, sure, sure.
Okay.
So all question you have taken, right?
Yes, sir.
Yes, sir.
Sure.
If you are you want, then I can share the answers for this and what?
No, no, sir. Let us practice first. Then, if you share the answer, then that would be great. Because if
Ah,
you share the answer, then that might be.
सर आंसर
with answers nothing will happen.
Sir, you
Don't
send the
worry.
answers in the next class.
कर दीजिए सर अभी वो ज्यादा अच्छा रहेगा क्योंकि हम तुरंत चेक कर पाएंगे ना कि सही रहा है अपना नहीं रहा है
Okay.
Sir, once come from the beginning, sir, so that I can check whether I've taken all the photos.
6 question would be there. Okay.
यस सर
Actually 7 was there, but one we have did initially.
सर सभी के एक बार आंसर शो कर दीजिए
Answer actually I have to also check.
नो प्रॉब्लम
Most of the time I also used to do along with you. So
No problem, sir. We can discuss in the next class.
yeah. Next class we will start from the question only. Okay. And apart from these 7 questions, I will also try to put great previous year or good questions for you. Actually, those without those formulas, this question would be more troublesome.
Sir, when is our next class, sir?
Actually, this thermo part we used to take on the Mondays, and each Monday from 7.
For the Indian, I have doubt in the Indian energy, and so for the Indian energy, it is taken as CVMRT, and for enthalpy, it is CPMRT. We define the two heat supplied only to differentiate the two process. So for when the enthalpy is defined at constant pressure and internal energy is for the constant volume, isn't it?
Mm-hmm.
Uh, so uh, we are defining the heat supplied as two only to differentiate the two process.
You are saying about like why, like for
Um,
constant volume is the termed as the change in internal energy, right?
yeah.
And for the this constant pressure it is dH, right?
Yes.
For the what is the first law of thermodynamics?
Uh, Q is
Del
equal
Q equal to
to
du plus
U plus
PdV, right?
W. Yes.
For the constant volume process, what will the PdV? Zero.
Yes.
So what will be the heat given to the system at the constant volume? Du, right?
D.
So what is the value of du? mCv.
Delta D.
Actually, du is not mCv delta t. dq is mCv delta t. But we are saying du also because du is equal to dq, right?
Okay.
What? It is not
Okay.
like heat is equal to the internal energy. Actually, internal energy is equal to the heat for that. What?
Okay.
Opposite we used to say like internal energy is equal to heat. In real, it is the heat that is equal to the internal energy. Right?
Yes.
Now
But
coming,
heat
now coming.
equal to mc delta T is for incompressible substances, sir.
No, 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 no. We will come to that also. So, what is the H U plus CV, right?
Yes, sir.
So, what is the DH?
Du plus dPdV.
Speedy.
PdV plus PdP,
PDP.
right? Hello.
Yes. Yes, sir.
Yes, sir.
So, what is this?
Work. Work. Work,
And
sir.
let's suppose let this is we are doing this. Let pressure is equal to constant, right?
Yes.
So, what will be the this time? Zero. Okay.
Okay.
So, du plus PdV what? First law of thermodynamics.
Yes, sir.
What is it?
dq.
EQ.
Q is equal to dH. Right?
Okay, sir.
Hello.
Yes. Yes, sir.
Yes, sir.
So for the constant process, heat interaction will be the dH, and dH is equal to mCpdt, right?
Yes.
Yes,
This
sir.
is only for the ideal gases. You also keep in mind that also. Because when we will study the properties of thermodynamic property relation, there we will see like enthalpy and internal energy will be the function of pressure, temperature also like that. When that will happen, so that we will see. Okay.
And for constant volume, is it also valid?
What?
Constant volume, it is also valid.
Same that internal energy is also the function of the temperature and pressure. But for the ideal gas, it is function of temperature only. That I will give question why. Why for internal energy and the enthalpy is the function of U and H is the function of temperature only for the ideal gas. Okay. If anyone knows the answer, next class tell me.
Please repeat the question again, sir, please.
Actually, in one thing, whether for all the gases, enthalpy and the this internal energy is the function of the temperature only. First question is this.
Yes.
What I'm saying? Enthalpy and internal energy enthalpy is function of temperature only.
Temperature.
If yes, then why? And no, so then why? Okay.
Okay, sir.
Actually, if you some person may not get, then till the end of also you can tell also. But at the end, you will come to know why it happens.
Sir, I want to confirm a thing that du for constant volume heat transfer process is mcv delta t. Since u इज अ पॉइंट फंक्शन, सो इसको कहीं भी यूज कर सकते हैं, ये है मेन मोटो सर हमारा।
Here, in for the internal energy, if we want to put internal energy in the any process, then we can use this. You cannot say like heat भी कहीं भी use करेंगे, not like that. We will use the internal energy same value anywhere, and same enthalpy value we will use anywhere. Okay, if we need to use enthalpy or internal energy. Apart from that, we have to calculate. Okay.
ओके सर। सर वो सर वो वाली चीज बता दीजिए कि ओपन सिस्टम के लिए माइनस VDP क्या है वर्क डन।
So H1 plus Q is equal to H2 plus W, right? And hello.
सर H1।
Yes, sir.
हाँ सर।
This is from the formula. Okay. And this is from the where?
SSSF flow
Stable flow energy equation. Now let's suppose a system is the adiabatic. So Q will be 0, right? Hello.
यस सर यस सर।
Yes, sir. Yes.
So what will be the W here? H1 minus H2
हाँ सर।
means a minus of DH.
जी सर।
Keep this. So what is the DH?
U plus PV।
DH.
DU
plus PdV
plus VDP।
plus VDP. Okay. So minus what du plus pdv?
डेल्टा Q
Huh?
DQ।
Plus vdp. And now if you think like a process is reversible, now till now we don't have any assumption yet, right? We
सर यहाँ पे
just we put like it is regulated, nothing more, no other assumptions here, right?
सर एक अजम्पशन है कि DU मतलब हमने वर्क को PDV ही मान लिया है, क्योंकि DU प्लस PDV हमने DQ लिखा है, इसका मतलब कि PDV ही वर्क है।
हाँ तो वो तो इधर से बोला हमने ना, DH को जस्ट डिफरेंशिएट किया है इधर, नथिंग अबाउट दैट ना। H की डेफिनेशन इट इज जस्ट डेफिनेशन ऑफ H U प्लस PV।
जी सर जी सर।
इट इज नॉट अजम्पशन।
सर इससे नेक्स्ट वाली लाइन में हमने उसको DQ लिख दिया है ना, DQ प्लस VDP, तो DQ क्या है? U प्लस PDV, इसका मतलब PDV क्या है? वर्क है, क्योंकि Q इक्वल टू U प्लस PV होता है ना, मतलब डेल्टा।
ओके तो चलो इधर से बोल सकते हैं कि रिवर्सिबल मान लिया, चलो इधर मानते नहीं, नेक्स्ट स्टेप में मान सकते हैं, कोई दिक्कत नहीं। रिवर्सिबल प्रोसेस, राइट?
जी सर।
नाउ assumption is reversible, and for reversible process dq is tds. हेलो।
जी सर सही है।
यस सर।
tds plus vdp. And this tds is 0 when tds will be 0, because this is the formula for work done, right?
Yes sir.
And here is the dw is minus vdp, and here this function is extra here, getting or not?
जी सर।
So this is the difference
Yes, sir.
in both. So what is this function, this term will make difference? This is the question. From here you will get the answer.
सर मेरा सवाल यही था कि जो DW माइनस VDP क्यों है ओपन सिस्टम के लिए?
ये
ये
ये भी तो ओपन ही चल रहा है ना, ये ऑल थिंग्स वी हैव डिड फॉर ओपन सिस्टम ओनली ना।
हाँ 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 जी सर। पर सर मेरे को यहाँ पे जो लाइन नंबर 4 है इसमें भी मतलब हल्का सा है कि DU प्लस PDV को हमने DQ मान लिया है।
हाँ,
और मतलब इसका मतलब PDV ही वर्क है क्योंकि DQ इक्वल टू DU प्लस DW होता है।
क्या
मतलब सर ये जो फोर्थ वाली लाइन में हमने DQ जो मतलब जिन टर्म का एडिशन को DQ लिख दिया है, DQ असलियत में क्या होता है? DU प्लस वर्क डन मतलब DW। इसका मतलब PDV ही वर्क है।
नहीं अदर टर्म, व्हाट अदर टर्म्स आर डूइंग देयर देन?
मतलब सर
यू आर सेइंग लाइक ओनली PDV वर्क इज वर्क देयर।
हाँ सर क्योंकि हमने उसको DQ में कंसीडर किया है ना।
It is from the first law, okay. Not think like PDV is only work. You can consider like PDV is also a term is there, and because it is open system, and this DH term is considering those terms. If you are not going and opening of this, then with DH will contain all these things in what is a DH value of H. Actually, you are missing from here, na. You are missing from here start. Why you have put W is equal to H1 minus H2? Let me know. Okay. What is H?
सर एंथैल्पी।
Not enthalpy. What is meaning of enthalpy?
सर कांस्टेंट प्रेशर पे हीट एडिशन
यही तो मिस्टेक हो गया ना, हीट एडिशन तो बाद में आया ना भाई। तो enthalpy is meaning what? It is the flow work. You in other words we will tell, right? What is flow work? Energy. What is enthalpy? H. 1 minute. What is H? H is equal to U plus PV, right?
Yes sir.
What is containing? U is the energy associated in the any system due to its temperature. Only in U temperature comes into picture. Huh?
Yes sir.
This is the energy. And what is PV?
So flow work.
Flow work. And energy associated with the flowing of that fluid, right?
Yes sir.
So you are keep on dissociating those terms here. So why this what the PdV will not come into picture? And now this PV associated with the change in pressure and change in volume, both work this will consider. Okay. So you are saying like here you consider only PdV work, not like that. This also is there, na. So this you have remained, but this will become zero. Why this will become zero? That is answer here. Okay.
सर मतलब इसका मतलब हम ये समझ लें कि ओपन सिस्टम में एंट्रोपी चेंज होता ही नहीं है।
अरे आइडियली नहीं होना चाहिए, हमारा ये है सिस्टम। Ideally that should not be there, but it happens. Why this dq becomes, we make this zero now? What is the physical significance of this?
मतलब कि हीट एडिशन
adiabatic, internally reversible adiabatic.
Means internally reversible should be also be there. Means internally no entropy will be generating there, but actually that not happens na. Internally always is every process is irreversible. So actually it should be there. TDS is zero. It is also assumption here. Okay. So in mostly interview this question will ask you why you are using this. So that you have to tell like there they will ask these questions. Why this becomes zero? So TDS is equal to here zero will happen. So what is the meaning of this? Means isentropic for this formula is valid for completely reversible process. Okay. Insulated and this Q0 means insulated only. Okay. This zero means it does not mean like it is reversible also. Okay, it is not like that. So but here TDS if you make zero, this is a completely reversible and isentropic process.
जी सर जी।
Entropy you put constant here na? So now it will become minus V.
तो मतलब सर इसका मतलब हम ओपन सिस्टम में हमेशा मान के ही चलते हैं कि ये कंप्लीटली रिवर्सिबल प्लस एडियाबेटिक होगा।
Whenever we are using this formula na, here we have assumed like it is completely reversible process.
जी सर।
And with this steady flow energy equation, it is general equation. अगर ये कहीं लगाया तो means it is general, not reversible, it is not like that. If you use minus VDP, it is more constrained equation we say.
जी सर, जी सर। सर इसका मतलब डीडब्ल्यू इक्वल टू माइनस वीडीपी में एक ही असम्पशन है कि रिवर्सिबल प्रोसेस है, एडियाबैटिक का कोई वो नहीं है असम्पशन।
एडियाबैटिक नहीं बोल रहे हैं पर टीडीएस को जीरो बोला है ना, तो इसको इसका मतलब हम लोग इसको बोलेंगे कि ये आइसेंट्रोपिक मतलब मान रहे हैं, इसमें एंट्रोपी जनरेशन नहीं है सिस्टम में।
सर आइसेंट्रोपिक मतलब कि रिवर्सिबल प्लस एडियाबैटिक।
यस, हाँ।
ओके सर, थैंक यू सर। हाँ सर, समझ में आ गया। सर आप एक एप्लीकेशन के बारे में भी बता रहे थे सर।
हाँ हाँ, ये क्या नाम है, एक मिनट, दैट आई हैव टू शो फ्रॉम माय मोबाइल।
वैसे एप्लीकेशन का नाम क्या है?
Someone asked that you people might know, like that dig you will put in the Play Store, you will get, because actually there you will get the study material. So the
dig,
d.i.g.
तो दीवाने आइए,
हाँ हाँ, study material you can get from there, so that is actually very good.
Okay sir.
So that will sufficient, sir.
More than for the study purpose, study material it is sufficient, but you have to solve the questions that and all.
Thank you very much sir.
Actually,
Thank you,
PK
sir.
Nag is for the more point of view for conventional too. So you cannot solve all the question from there.
What is the name of the app, sir? D.I.G.
D.I.G.
Sir, something called Divane IES
For
and
YouTube,
Git.
that will become YouTube channel. Actually, from there also you can get lot of things.
Sir, repeat once again.
You just put like D.I.G. Okay, then fine.
Thank you, sir. Thank you.
Okay, then.
Thank you
sir.
See you. Bye.
Thank you, sir.
Bye, sir. Bye.
Thank you.
Thanks a lot.
Yes, sir. Thank you, sir.
Thank you.
May I leave now, sir?
Yeah, sure, sir.
सर थर्सडे और संडे को भी क्लास करवा दीजिए सर।